Hello good people, I'm going to explore how to deal with directly proportional ratios. In this first problem, we are told that the correct and safe dosage of an antibiotic drug is 23 milligrams per 100 milliliters of a saline infusion. How much of the drug should be present in a 460 milliliter saline solution? A good place to start is to identify the variables involved. In this case, we have milligrams and milliliters. In fact, we have 23 milligrams for every 100 milliliters. And we are asked how many milligrams will there be if we use 460 milliliters. To decide on the mathematical approach, I firstly need to identify, is this a directly proportional scenario or an inversely proportional scenario? I can see that the value for milliliters is increasing. I need to know whether the amount of milligrams is going to increase as well, or will it decrease. If the concentration of the solution is to be kept the same, I need to increase the amount of milligrams as well. So I could say that both of my variables are increasing. Therefore, this is a directly proportional scenario. I like to write a little d here to remind me of that. It turns out that there are different ways that we can solve this problem, and I'm going to demonstrate 3 of them. For the first method, I want to know the factor by which the amount of milliliters or the volume has increased. In other words, by how much do I need to multiply 100 to get to 460? A different way to ask this question is, what do I get if I take 460 and divide it by 100? If I perform the division, I end up with 4.6 as my result. And now I can take this factor and multiply it by the amount of milligrams. And that will give me 105.8 milligrams. Now I could say that a 460 milliliter saline solution should contain 105.8 milligrams of the drug. Let me look at another way to solve this problem. And this time I'm going to use this little d that I wrote before. D stands for directly proportional, but it also stands for divide the numbers of the ratio. What do I mean by that? Well, I'm going to take the first ratio and divide those numbers. And because the ratio has to be the same, I'm going to write equal, and then I'm going to divide the numbers of the second ratio. Now I need to solve for x. In order to do that, x needs to stand alone on one side of the equation. Currently, this 460 is in the way. I'm dividing by 460, which means to transpose it, I need to multiply both sides by 460. And according to my calculator, this will give me 105.8 equals x. It is the same result. The third method will use units to guide the solution. So the initial dosage of the drug is in milligrams per milliliter. And the second dosage of the drug should also be in milligrams per milliliter. In the first instance, the milligrams are 23, while the milliliters are 100. In the second instance, the milligrams are the unknown, while the milliliters are 460. Once more, I need to transpose 460 by multiplying both sides by 460. And so I will have 460 multiplied by 23 per 100, and all of that equals x. Recall that 23 per 100 is the same as 23 over 100 or 23 divided by 100. In essence, I'm repeating what I have done here in this step in the green. And no surprise, I will end up with the same result. 105.8 equals x. Which method you choose to use is up to you. Let me explore another problem. I have decided to impress a certain special someone by baking them a cake. The recipe I'm using requires 240 grams of flour, 160 milliliters of water, and 80 grams of butter. The first question is, what is the proportion of butter? And the second question is, if I use 350 grams of flour because I want to make a bigger cake, how much butter will I need? I'm going to start by creating a table that lists the variables involved. And because this question is also asking me for the proportion, I'm going to add the total column as well. Considering that my cake consists of 240 parts flour, 160 parts water, 80 parts butter, the total number of parts is 480, all of the parts added together. I'm going to answer the second question first. So I have 350 grams of flour and I want to know how much butter I will need. Considering that the amount of flour has increased, should the amount of butter increase or decrease? Well, if I am to maintain the same ratio, the amount of butter needs to increase. I am making a bigger cake. This means that this is a directly proportional situation, and so I like to write a little d here. My first solution will look at the factor by which the amount of flour increased. In other words, by how much do I need to multiply 240 to get to 350? Or, alternatively, I could ask myself, what do I get if I divide 350 by 240? And the answer is 1.4583 recurring into infinity. And now I can take that value and multiply it by 80 grams of butter. And that will give me 116.6 recurring into infinity grams of butter. Considering that this is baking, we would probably round it to about 120 grams. Let me solve this a little bit differently. I'm going to use this d, which stands for directly, but it is also telling me to d-divide the numbers of my ratio. And so I will have 240 divided by 80, and that will equal 350 divided by x. 240 divided by 80 is 3, and so I will have 3 equals 350 over x. I cannot solve for the unknown so long as it is beneath the division line. So I need to multiply both sides by x, and that will give me 3x equals 350. And then I need to transpose the 3 by using division. 350 divided by 3 is 116.6 recurring. So once again, I get the same result. Okay, now that I have answered how much butter I will need, I'm going to calculate the proportion of butter. Recall that to calculate a proportion, I need to divide the part that I'm interested in by the total. In this case, I'm looking at butter divided by total. According to the original recipe, there are 80 parts butter and 480 parts in total. This fraction can be simplified to 1/6. And if I wanted to express this fraction as a decimal, it would be 0.166 recurring into infinity. For neatness sake, let me round this to 2 decimal places and express it as 0.17 rounded to 2 decimal places. Recall that we can express a proportion as a percentage too. I would need to take this decimal, 0.17, and multiply it by 100%. That would give me 17%. And so I could say that the proportion of butter in this cake is 0.17, or 17% of this cake is butter. Now, before all of you go sweet on me, let me just say that is all for now, and I will see you on the flip side.